In this video, I'm going to demonstrate how to do relaxation calculations on bilayer graphene. I will do this using materials project and DFT as installed in VASP and VESTA for the visualization. So you can go to this website materials project and register yourself and get the VASP files for the graphite. Once you have this file, you can open it up and you will see there are 4 files: in-car, kpoints, postcar and portcar. You can keep the postcar and delete the all 3. Now you can open VESTA to see how the graphite unit cell looks like. In VESTA, we can design the graphene unit cell by deleting one of the layer in graphite and all the periodic atoms in the remaining one layer. This unit cell we can save as a XYZ file in the same folder. I'm giving the name 1, but you can choose any, and do not save the hidden atoms. You can open this XYZ file and compare it with the Postcar file. Now copy all of the atomic position from XYZ file and replace all of the position in Postcar file and change the atomic coordinate style from direct to Cartesian. Now delete the atomic symbols and change the number of atoms and save this Postcar file. Open this new Postcar file in VESTA and now you see we have a unit cell of graphene. Just by using the same Postcar file, we can make a bilayer graphene by copying these 2 atoms again and changing the number of atoms and changing the z coordinates of the 2 of the atoms. There you go. Now we also have the bilayer graphene. Now you can perform DFT calculations on this unit cell, but we're gonna do on a larger unit cell just to get a feel of it. So we just have to change the rotation matrix to 4x4 to get the 4x4 unit cell of the bilayer graphene. So as we did for the graphene unit cell, we have to delete all the atoms outside the unit cell, and along with these atoms we also have to delete on the boundary lines just to preserve the boundary conditions in this unit cell as well. Okay, so now let's save this file as XYZ in the same folder. I'm using number 2, but you can use any name, and keep in mind to exclude the hidden atoms. Now open this 2.xyz file and copy all of the atomic positions and replace all the atomic positions in the Postcar file by these atomic positions. In the Postcar file, delete all the atomic symbols and change the atomic number to 64 in 4x4 unit cell. Okay, so one more thing, we have to save the lattice parameter of the 4x4 unit cell, so we have to export it as a Postcar file. I saved it as name 3 in the same folder. We can open this Postcar file 3.postcar.wasp and copy the lattice parameters from this file and then paste it or replace it in the Postcar file with the previous lattice parameters. Now we have the unit cell for the DFT calculations. We just have to add the vacuum in the Z directions. I don't need these files anymore, so I can just delete them. We can open this Postcar file in VESTA and measure the distance between 2 carbon atoms in the Z direction, which is exactly equal to 2 as we set up in the Postcar file. And we can change the lattice parameter C in the Postcar file to 22 to add 20 angstrom of the vacuum in Z direction. And finally, we have the unit cell for bilayer graphene to perform the DFT calculations or the relaxation calculations. Okay, now let's prepare the three other files, in-car, k-points, and Postcar file. In the in-car file, we have to mention the energy convergence threshold, which is 10 to the power minus 5, and the cutoff energy 400 electron volt, and then NSW 3000 and IVDW for the van der Waals forces. So we can also check the pseudo potential file, which is Postcar, and we can see that this has a carbon pseudo potential file. And at the same time, we also can check the k points file. In the z direction, the k point value must be 1, and we can check the Postcar file. So all the file looks perfect in order for the calculations. Okay, so now I can upload these files to the supercomputers and also add the script file. Now we are ready to submit the calculations to the supercomputer, and we can see that the calculations are submitted to the cluster. Okay, so now the calculations are finished, and we can download the output files to the local computer, and we can check them and all the information that we need from the calculations. So these are the files from the simulations, and we have to check the outcar file for the total energy of the system, and this is 594 point something something is the total energy of the system. We can also compare the Postcar file, which is the relaxed structure, with the Postcar file, which is the input structure in the VESTA. So we can see here in VESTA that the Postcar file has more distance between the layers as compared to the input structure Postcar. So that means the distance 2 angstrom is not enough for the relaxed system as we considered in the Postcar file. And you also can measure the distance between the layer in the optimized structure in the VESTA. Thank you very much for watching the video. I'll see you in the next one.